I wouldn't necessarily tie all that together, but good afternoon, everyone, and welcome to MASQUE. I will hand it off to the chairs now.
All right. Thank you, David. Welcome to MASQUE in Vienna and/or online, specifically and online, because please go join the on-site tool if you're in the room and have not yet already. Just a quick reminder that this session is being recorded. We've got a link in this slide or in its equivalent PDF to both the on-site tool and the fully remote video stream. If you do not join the on-site tool, you won't be on the blue sheet, so make sure you do that. You can enter the queue in both tools with the raise hand button and leave it with the lower hand button. If you are on site, make sure that you enter the virtual queue because that's the only place where we will be dequeuing someone from, although you will need to get up to speak at the actual physical microphone. If you're remote, when your turn comes, just press the microphone button to send audio and press it again to stop sending audio. This is the IETF Notewell, especially as it's Monday. Please make sure that you've read it recently. These are the terms under which we collaborate here at the IETF. We've got some helpful links to our agenda and other notes in here. This is mostly for the PDF later. And our agenda today. First things first, we need a Jabber scribe and a note taker. Somebody willing to volunteer to reflect notes at the in-person or virtual mic and or take notes. Thank you, Alan. We've got a Jabber scribe. Someone to take some notes.
Who else can help with minutes here? We need that to get started, people. Thank you. All right, Martin Lucas, thank you so much.
Wonderful.
And that's Martin
Thank
Duke.
you, folks. Appreciate that. Let's take a quick second to batch the agenda if anybody would like to reorder or move things around. What we've got up are our main active drafts. So we've got H3 datagrams in Connect UDP, and then after that, we will be doing some IP proxying support and calling it a morning. All right, that means David.
All right, I'll try to share locally.
All right, take us away.
1 second, I'm trying to get the clicky to work. Good afternoon. Wow, really had to eat this thing. Good afternoon, Vienna, and good morning, good evening, good middle of the night, the entire rest of the world. Thanks for coming to MASQUE. So my name is David Skenazy, and I'm going to be talking about HTTP datagrams and Connect UDP. So first off, quick note about the hackathon. We had a quick table, which Lars decorated to also make a MASQUE table. This joke never gets old. We didn't quite get interop in the room, but we did, amusingly with the latest drafts, since they're wire format compatible with the previous ones, assuming you just disable contexts, we already have interop, which I copied the matrix from last time. So we're already in good shape implementation-wise, even though those are pretty new and only came out 2 weeks ago. But let's do a quick recap of where we are. So the focus of these two drafts is to build Connect UDP, which is like the HTTP Connect method, but for UDP instead of TCP. There is interest in other places to do datagrams as well, so we split into two drafts, the first one being HTTP datagrams, which is used, for example, in web transport, and then the second one being Connect UDP, which has a dependency on HTTP datagrams. So over the course of the last year and a half, we redesigned, I think, a total of 4 or 5 times. I lost count after a while, the core design of this. So since we were kind of going in circles, we decided to go with another approach. We formed a design team, which met a few times, and we came out with an output at an interim a few weeks ago, and got consensus. So all that was good. That's been merged, and now we have these new drafts. So I'm going to quickly go over what the drafts do right now. So first part that is in the HTTP datagrams draft is the Capsule Protocol. So the Capsule Protocol runs on the data stream, which is what we call the data that goes after the headers. So in HTTP2 and HTTP3, that's the data frames. In HTTP1, it's after the 2 new lines after the header block. And it's a bidirectional sequence of TLVs. And it's meant to be end-to-end if there are any intermediaries in the middle. And any method can choose to use it or not. Connect UDP does. And so that allows it, for example, to send datagrams. And there's a little header that we added as well, so you can tell intermediaries that the Capsule Protocol is in use. It's not mandatory, but it exists. And intermediaries are able to translate between versions of HTTP like they do for other methods. And for HTTP datagrams, the difference between those and the quick datagram frames is that the HTTP datagrams are associated with a currently open HTTP request stream. So what that means is they're always tied to an open client-initiated bidirectional stream. And so you can still send them, kind of think of it as a sidecar, but datagrams don't exist in a vacuum. They're always tied to a request. And so the formatting is there on the right. So when you send a quick frame, that is the quick datagram frame, it has the quarter stream ID in it followed by the HTTP datagram payload. So we divide it by 4 because all the client-initiated bidirectional stream IDs are multiples of 4. And we also introduce a datagram capsule. So capsule being a sequence of TLVs, the T have an INR registry, and we define a single one, which means datagram. So if you receive one of those, it means the same thing as receiving this datagram quick frame. In quick, you generally will want to use the datagram frame, but if you're using HTTP1 or HTTP2, this allows you to still support things like ConnectUDP over older versions of HTTP. And yeah, that works for all known versions of HTTP. So the biggest point of contention that we had in HTTP datagrams over the last year and a half was extensibility and demultiplexing and what we had with context. So the consensus that we landed on was to take that out of the HTTP datagrams draft and put it inside ConnectUDP. So that means that, for example, for web transport, it doesn't have this feature because they didn't see a need for it. So when it comes to HTTP datagrams, we're pretty much done. We've resolved all the issues. We'd like to move forward because that unblocks other working groups like web transport. And I think we're ready for working group last call. So I'd like to kind of pause here and ask like the chairs what they think, or anyone on the floor if they have thoughts or comments. Not seeing anyone get up in the room. Chairs, what do you think?
I think we're looking pretty good. I think we'd generally be aiming to initiate a last call for this on the list after this meeting. But that is also a massive thanks to a whole lot of folks who have put a lot of time and effort into this, especially before our previous interim and a lot of that stuff. So a thank you for that. And now that the slate is looking pretty clean, we're probably going to go and start a last call right after this meeting wraps up.
Thanks, Eric. I see Maria in the queue.
Yeah, hi. Is it working?
It's working, but please state your name.
Mirja Kulevin. Yeah, I think this looks pretty good. It's pretty clean, and it's probably ready. What I would like to see is have at least one draft that uses the extension and you know, think a little bit more about if we did it right at the end.
So there is no more extensibility in HTTP datagrams. The extensibility is inside ConnectUDP.
Sorry, I thought we were talking about both of them.
Well, right now we're just talking about HTTP datagrams.
Yeah, no, that's easier. Okay.
Okay, but hold that thought. I'm going to keep going then for ConnectUDP. Any other thoughts from anyone on HTTP datagrams before I switch over to ConnectUDP? Eric?
Sorting out the queue. Just wanted to ask, is there anybody who thinks that we should not move HTTP datagrams forward without ConnectUDP or anything else? Because I think our intent here is to move HTTP datagrams forward, especially because there's other working groups that are depending on it sooner, and then continue to wrap up ConnectUDP and then ConnectIP afterwards. Excellent. I will take that as a resounding silence. Thank you.
Tommy in the queue.
All right. Yep. So I definitely think we're ready for working group last call. I would just note as HTTP chair that when we send that out, let's also send a note to the HTTP group to also review, since there may be some folks in there who haven't been paying super close attention, and it would be great to get their review kind of alongside the rest of the working group.
Yes, absolutely. Thank you.
Awesome. Thanks. Okay, moving on to ConnectUDP. So ConnectUDP, it is not an HTTP method. It was in the earliest version of the draft, and we kind of kept the name, but it is now an HTTP upgrade token. So HTTP upgrade tokens allows you to use a mechanism in HTTP1 called upgrade, where you send an upgrade header with this token. So in this case, we picked ConnectUDP, and then it replaces the protocol on the wire with something different. So that, in this case, is the Capsule Protocol. In HTTP2 and HTTP3, HTTP upgrade tokens are used for something called extended connect, where you send a method of connect and a protocol of connect UDP. And this is documented for HTTP2 and RFC 8441, and we have a draft for the same thing HTTP3 that has already been approved by the ISG. So we have a normative dependency on that, but we see this draft as happening before connect UDP anyway, so we don't see a problem there. Then on the topic of extensibility, we kept the concept of context IDs from the previous HTTP datagram drafts, and we moved them into connect UDP. So if you look at the wire format image here on the right, after the quarter stream ID, which is part of the HTTP datagram layer, you have a context ID, also a variant, quick RFC 9000 variable length integers. And we define a specific meaning to context ID 0, which means UDP payload. So every time you see one that has 0, you put that in your UDP socket, and vice versa. When you receive a packet on that socket, you put it in a datagram and send it back to the client. And all other numbers exist for extensibility. And we decided that they are dynamically allocated, which means that each, like both the client and the server, have a way to generate new numbers that haven't been used before. The simplest one is you just keep a counter. So you start at 2 and you return 2 and then 4 and then 6 on the client, and same with odd numbers. But we don't mandate exactly how you do that. For example, if some future implementation wants to reserve the low variant numbers, which only take 1 byte encoding for some things, they can do that and give them out of order. So that's kind of all we do to specify them. And from the thoughts that we've had for our extensions, this seems to be powerful enough to enable any extension that we thought of. Because you can, for example, create an extension that adds information to UDP, let's say ECN bits, and just define a new context ID for that. Or you could define a context ID that sends information that's unrelated to a specific packet. Let's say you received ICMP, which is not tied to a UDP packet necessarily. And so we introduce in this draft the concept of registration, which means that we, when an endpoint decides, okay, I've picked number 4, and number 4 means this, that's how it informs the peer of that format and of those formats, or that format and those semantics. And we don't specify registration exactly. We say that you can use HTTP headers. We say that you can use new capsules, because headers are kind of simpler. You're guaranteed to have them like during the request response cycle. Capsules are more powerful if you need, for example, for something like compression, where you don't necessarily know what the value is at the request response time, you can add them later. So you have the option to do both, but we don't define how to do it. We say, okay, we leave this as an exercise for future extensions. And I kind of want to pause on here because I know some folks had thoughts. My personal preference is to kind of keep it like this. I would rather keep this draft simple and allow us to move it forward more quickly. But I want to pause here and make sure that the working group agrees with that statement. I see Ben Schwartz in the queue. Go ahead, Ben.
Hi. Oh boy, echo. That's exciting. So yeah, I'm one of the people who has expressed some concern about this. You know, I tried to drop a draft that sort of made use of this and found that I ended up writing a lot of boilerplate to explain how this registration and negotiation worked, and that I was getting lazy and leaving out parts of it that I thought I could probably get away with not dealing with, like deregistration or handling error cases. And so I worry that we're going to end up in a situation where we have extensions that all have slightly different ways of registering, and many of them are missing important error handling and garbage collection cleanup type functions, and we don't get as much code reuse as we could. That said, I am okay with this. I think that maybe the right approach here is to pretty quickly try to come up with some extensions that we think really do things right and provide a template that that hopefully subsequent extensions can follow.
Thanks, Ben. That makes sense. Ted?
Ted Hardy speaking. I agree with you that probably you will have use cases where you want to do either HTTP headers or capsules, but I think what you probably should do now is pick the one you think will be the most useful quickly, put that in the draft, and note in the draft that the other might be defined as a later extension. That means you don't define both paths as a later extension. You end up with something in the draft that says, this is a mechanism that is known to work with the worked out issues that Ben was alluding to, so that somebody who wants to say, okay, I'm going to do this with an HTTP header knows how it works, and somebody who decides that they really need a capsule knows that, well, I need all of the things that are in that plus whatever the capsule needs. But that also means I'm defining an extension as the cost of my going off the base spec. Now, I would actually say, for the reasons you already elucidated, that HTTP headers would be the one I would put into the draft now, if you are going to put one into the draft. And I think functionally, you're not going to be able to put this complexity off long, since you're going to want to do this soon. So you might as well tackle it now. You could put it in a different document if that helped you, but I would do it now.
Thank you. My personal preference is to keep it in a different document because I see Ted gives me the thumbs up, because the use case that we have for actually putting this in production doesn't need extensions just yet, and it'll be easier to interoperate with folks if we have a standard for like that what we need. But having a draft for this that we start right away sounds great to me, honestly. Thank you, Ted. Mike Bishop is next.
Okay. Do I have audio yet?
We can hear you, but you're very quiet. You have to eat the mic.
Okay. So I'm going to, I feel somewhat hypocritical because the H3 draft does kind of say you have to figure it out, but it gives you a suggested mechanism, which is setting a setting and defining a setting as part of your extension. You don't really have settings here, so I'm not sure how you would hand wave this away. I feel like it needs to be defined. It also helped in H3 that we had several extensions that were already in progress when we wrote that. So I think a separate document would be fine, but we do need to start it, and we do need to actually define this and not just leave it for each extension to figure out how they want to build it.
Thanks. So on the topic of, like the analogy with settings, we have an equivalent, which is HTTP headers. So let's say, and you're right that maybe in this draft we kind of add a bit of text explaining that's what you use. But since the Capsule Protocol is only in use and HTTP datagrams are only in use after the HTTP request and response have been received, you can negotiate any kind of extension by sending them in headers. So that gives us kind of our extensibility joint for negotiation. And then the context ID allow you the rest. Thanks, Mike. Martin Seaman?
Martin, Protocol Labs. I'm wondering.
Speak closer to the mic, please.
I'm wondering how extensions compose. You've already mentioned ECN bits, and in the draft there's a example extension for timestamps. So you would have one context for the ECN bits, one context ID for timestamps. What happens if I want to send both ECN bits and timestamps? Do I need another context ID for that?
That's a great question. So when we talked about it, that's how you would do composability of extensions, is say, if I want to send both the ECN bits and the timestamp, I use this to be defined negotiation to say this context ID means a UDP payload with first the ECN bits and then the timestamp and then the UDP payload. Martin Duke.
Martin Duke, Google as an individual. Like headers, requested responses are a pretty obvious extension joint, but I will say the downside of that is that you can't use the extension necessarily in the first flight, depending on the specifics of the extension. If I want to send a request with this extension negotiation and then immediately send datagrams with this thing, like I don't know that the server can accept them. So it's a downside. It's not a showstopper, but.
No, so that's a very good question, and we actually have a solution to that, I think, in the draft, and I need to double check that if that's written down or just in the back of my head. But all we need to say is that you drop context IDs that you don't know. And so you can, let's say, as a client, we called this zero Rtt extensibility in previous meetings, if anyone remembers. But the idea is if you want to send something in your first flight, you can send I want to use this extension in the header, and in another header say context ID 4 means this new extension, and then you send a datagram with context ID 4. If the server supports it, it says with its server response headers, yep, I support this, and then it processes the datagram, and if it doesn't, that header gets ignored, the datagram gets ignored, and it's lost.
Oh, I'm sorry, the datagram is ignored.
Yes,
okay.
And but that is a good point. I will double check. It all relies on saying that you just silently ignore context ID you don't know, just drop them. And I need to double check if that's actually in the draft. If anyone has it open, let me know. But otherwise, we should say that.
So I mean, I guess okay. So I mean, the ECN case is the one that I certainly have at the top of my mind, and that certainly sounds fine. But what you're describing is also an attempt to use 0 RTT essentially gives you a 1 RTT penalty, which also is not great. And I'm pointing out problems here. I don't really have a solution, but I'd encourage you to think a little more about if there's some way to a more robust system for this.
So there used to be in the draft, and the kind of consensus of the design team was that this was too complicated, so it was removed. And that's kind of, we ended up with the current design. I personally preferred that feature, but I think I kind of agree in hindsight with the rest of the working group that keeping this simple, even though we might have some edge cases like that, is probably worth it in the long run.
Okay, thanks.
Cool. Ecker's in the queue.
Yeah, I mean, on the topic of this zero RT extensibility, I mean, as I understand the mechanics situation, that's a great for you, isn't it? I'm just going to keep talking so your head has to do that forever.
Sorry, Ecker, I have a really hard time hearing you. Can you speak closer to your microphone, maybe slow? The acoustics aren't great, and it's probably because I'm behind the speakers here.
Yeah, hard for me to get much closer without having my face in it because it's attached to my camera. On the topic of having extensibility in the first flight, as I understand the mechanics of the situation, you either have to. Oh, that's great. I have the echo on your side. Don't you guys have echo cancellation?
No, I need to put the microphone down. Sorry.
Well, it's not helping. So as I understand the mechanics of the zero RTT extensibility here, unless you have mandatory extensions, even if the extensions are self-describing, you can't use them guaranteed in the first flight because their side might reject it. And so as a practical matter, the most you could possibly do is announce them in the first flight and then still have the ignore behavior that you described here. I suppose you could have extension persistence from previous handshakes, the way we do other zero RTT features, but as far as I can tell, the physics of the situation just dictate that there's no way to be absolutely sure the extension will be acceptable in the first flight and start using it for anything that is critical path and will cause disaster if it fails. Am I incorrect about that?
I wouldn't say it's a disaster if it fails. I would say the datagram gets lost. So if it's something critical, let's say you want to send your quick initial in a UDP packet for this, and you want to send it with ECN bits, and the server, the proxy doesn't support the ECN extension, it's going to drop that datagram, tell you, and then you're going to back. So you're going to lose a round trip for that connection establishment, and that's pretty bad. So I think in general, probably when we get around to writing the ECN draft, we might say, unless you have a reason to know that the proxy supports ECN, like you're saying, maybe we remember it, I would just like not use it in the first flight because it could cost you a round trip. But the failure mode is just that datagram gets lost. It doesn't get misparsed.
Right. I think you and I are on the same page here. What I'm saying is you can't use extensions for anything where if it was lost, it would cause failure.
That's right.
Okay. Then I think we're on the same page.
Cool. Thank you. All right. So it sounds like what I'm getting from the room is folks are overall okay in not having this draft define the whole system, but that we should start work on a separate draft to actually define how to do registration. And that sounds great to me. All right. Now for everyone's favorite game, let's close some GitHub issues. One of the things that I didn't discuss too much yet is how you configure clients. So for HTTP Connect, either in the proxy settings of your computer or OS or of your browser, you put in a proxy host and path. Sorry, host and port. What we do instead for Connect UDP, and the Connect IP draft for that matter copies that as well, is we put in a URI template. And so it's kind of a thing that looks like a URI, which has these magic variables, target host and target port, that anytime the client wants to do a Connect UDP request, it swaps them out for the actual host and port that it wants to talk to. And so here are 3 examples on the slide. URI templates are a little bit complicated. We added some text pretty recently. I forget if it got into the last draft 2 weeks ago, or I think I might have landed that PR after the draft caught off, so sorry. I added a paragraph that tightens up the rules on the URI template, so you can't use some of the really crazy and hard to parse syntax in there. And I think that makes it a lot more wieldy. However, one thing we thought of was a lot of existing OSs have a UI where you can only put in the proxy host and port. You can't put in a URI. And we kind of probably want to work with those. So the draft defines something called a default URI template, which is if your UI kind of has this limitation, here's the URI template you should use. So it's pretty simple. You just use the proxy host, the proxy port, and 3 slashes with the target sort and target post there. And I think it was Eric Nygren who filed an issue in saying, well, should this use .wellknown? I don't personally care much. Does anyone have opinions on which way we should go here? Do we keep the current one, which is short, or do we move it to something at .wellknown? I see Ben Schwartz in the queue. Go ahead, Ben.
Hey, I think .wellknown is correct here.
Sorry, say that again a bit slower.
I think .wellknown is the correct place for this.
Okay. Anyone else have opinions? MT+1's in the chat apparently. Thank you. Okay. The one that I put up there, .wellknown /mash /UDP /target host /target port. Does that work for everyone?
You guys can hear me?
I see Rajiv in the queue. Go ahead.
Yes. One point that I have is in many cases, a lot of intermediary hosts, especially proxies and CDNs, do have some special handling logic for well-known, which we already use for a number of other protocol activities. So do you think this might be something that interacts badly with existing rule sets around the .wellknown path?
So I don't. So thanks for your question. I don't know if I have a great intuition for that. My gut feeling is you probably want. Well, you're going to need some special handling for this path if you're doing Connect UDP. Like this is fairly different from most existing HTTP methods. So probably having that well-known maybe makes that easier. But in our implementation, like we don't have any specific rules that tie to the well-known prefix. So I don't see that as
Maybe
well.
some text in the draft around the fact that this might be something that interacts with existing rules, and implementers should, maybe just keep an eye out for such interactions. Could be part of the draft, just as a warning to people who are, implementing functionality around this.
Okay, thank you.
That's
Yeah,
just
that
my
makes
thought.
sense. We can add some text to make sure people don't get it wrong. All right. Unless anyone objects, I'm gonna write a PR to move to that well-known path at the bottom. All right. And now for another fun one. So for HTTP2, we use extended connect, and the method there is connect. For HTTP1, we use upgrade. Upgrade works in theory with any HTTP method, and whatever we put in there doesn't really have semantics, because we could say it's whatever. Any proxy that correctly implements this spec will handle it. Doesn't matter. We don't get any information out of the method. The draft currently says we should use connect for consistency with what we do for H2 and H3. And Eric, I believe, pointed out that we should use get, because that, or maybe we can use get, because that's more consistent with what WebSocket uses when it does upgrade, which is kind of the really only widely deployed use of upgrade that I am aware of. Lucas pointed out on, oh yeah, we discussed this at the last IETF meeting, and kind of the consensus was let's ask the HTTP BIS working group. So I wrote an email and got 0 replies. So clearly they care. And Lucas pointed out that Connect might cause more deployment concerns. So how about we just use get? If anyone has thoughts or opinions, please come to the mic. MT is in the queue, go ahead.
Audio going out is wonderful. So is cacheable by default with heuristics. So I think there's the possibility that a very stupid cache might accidentally cache something that it shouldn't. But post is probably okay as well. But whatever.
So, sorry, I didn't quite get all that. The audio is surprisingly bad from the front here. You kind of ended with whatever.
So I put it in the chat, but if you have a cache that takes a get.
Do you want me to read out from the chat? So MT said, what about a caching proxy that falsely caches all gets?
Ah, caches. I heard hashes. Thank you. Okay. No, this is really terrible. No, that's a real concern. Lucas, since you're the one who was preferring get to connect, you want to come say something? Because it's true that get is marked as cacheable, whereas connect is not.
Hello, I'm Lucas. Can you hear me?
Yes.
Yes, great. I mean, the problem would exist for get WebSocket upgrade then. Like, what I like about using get is the symmetry and the asymmetry between H1 doing what it does and H2 and H3 doing what they do, and how it works already for WebSocket. If we followed this, it would, at least if there's caveats drawn out in caches for WebSocket today, they could still look at the upgrade header. Even if they didn't look at the contents and just say, oh, this isn't cacheable, even though it probably is. In respect to the Connect, Connect is just weird, and trying to build something new on top of it with 1.1 doesn't fill me with a lot of confidence. If we had to, I probably, again, could carve out another caveat for it, but it just seems like, I don't know, this or that, whatever.
Yeah. Oh, I'm very much in the whatever camp. Thinking more about caching. So this is for the case of some box that doesn't support this. So they're probably going to send a 404 or some other kind of error. If they cache that, that's not a problem because the answer is going to be the same every time. Ecker's in the queue?
I'm just having a little trouble understanding what the scenario in which this would be a problem is. Can someone lay it out for me?
So the idea is if you're talking to, and granted it's an odd scenario. Let's say you set your proxy settings to, I don't know, davidskenazi.com. I don't support Connect UDP on there yet. The same server runs mask.uno, but that's different. And you try to do this, you're going to get some, you don't want the proxy to catch fire. You want it to properly say, nope, I don't support this, go away. And we're trying to think about, like, in all cases, it's nothing really too bad, but we want to find the least dramatic way for the proxy to fail, I guess.
Okay, I feel like my response to this, as to every other concern about proxies that do not speak this problem, is don't do that. You don't accidentally get connected to a proxy which has the wrong semantics. You mistyped or you're misconfigured. So I actually do not care the proxy, and the proxy shouldn't catch fire with any data sent to it, obviously. But I don't care if it hangs indefinitely and you have to wait time it out because that's a misconfiguration. So I just don't understand how the situation arises. So I don't understand why using connect to the problem.
You're right. It's a theoretical concern to some extent. I'm with you there. Rajiv?
Again, what everyone to think about is the fact that traditionally, when we have been talking about devices that kind of act like firewalls, intercepting proxies, and stuff like that, they have always treated Get and Connect very differently because it's the traditional way that they've been used.
Sorry. I tried to speak in the mic in front of the microphone, the speaker, and that was a terrible idea. I apologize, everyone. What I was going to say is I can't hear you, and from the looks in the room, we can't hear you at all. If you could maybe type it in the chat, and then someone can relay.
Can you hear me now? Is it better now?
Yes, that's much better. Thank you.
Okay, great. So just moving a little closer to the mic. So I was just making a point that a lot of network transition and edge devices like firewalls or intercepting proxies have traditionally had very different conceptions and security rules around gets and connects because of the way they've been used. Like you said, traditionally 1.1 and prior connect has always been something that was a tunneling system and gets a very different security handling than any request with the get method. So that might also be something that a lot of people have been changing because of WebSocket, but I don't see that having changed so much. So it might actually make sense for us to stick with Connect because that's closer to the kind of security handling that people expect around this kind of traffic. Again, just a thought over here.
Okay, thank you. Eric?
I think is it theoretical or not? I think where it really comes into play is if you start having multi-tenant services. So if you have, for example, a CDN node that wants to be handling various things, the traditional connect method does not have good multi-tenancy support and becomes really messy. And having the connect method have different semantics between extended connect and non-extended connect, especially in a multi-tenant environment, gets extra messy. I think Martin's suggestion of post, if that works, might also address this well.
My only problem with post is then I can't resolve this with a coin flip anymore. I need a like 3-sided dice. How do people feel about post? That's fine by me, because I think I'm very squarely in the Ecker's camp of this will never happen, and at least speaking for myself and I think quite a few others, we're never going to actually implement this over H1. We're going to use H2. We have to implement H2 because some networks block UDP and QUIC and H3, but H2 or H1 is inside TLS. So like the only place where this will probably be used over H1 is inside someone's network between their front end and their back end. And if they're implementing this, they're going to fix their network and their firewalls to make it work. So I really don't care about the answer. Let's just pick one. Does anyone object to post? Ecker?
I mean, I kind of do. We have a thing for this. It's called connect, and overloading post yet again seems gross. That was my objection to get too. I guess I don't understand Eric's point. I mean, I don't love connect, but I don't understand Eric's point about why connect is a problem.
So I think it comes down to someone who wants to deploy this on some backend when they have like some appliance in the middle, like a firewall or something, that's going to treat it weirdly. And I think that's where the fears come from. I think. I'm not entirely sure, to be honest. MT?
Oh, good God, that's so slow. So I think the key here is that as soon as you start an upgrade header on the request, it doesn't matter what the method is. What we've heard from people is that if you happen to use connect in combination with upgrade, they don't know what will happen, as in things might explode. So I'm happy to avoid connect, but then look at just anything else.
Okay, well, we have someone who wants connect and someone who wants anything but connect. This is going great. Mike Bishop.
Okay. So I think the issue with connect is that HTTP handles connect very weirdly. For basically anything else, the method points to a resource, connect points to the target. And so what Eric was alluding to is something we've talked about in HTTP before, and I think here before, that it might be nice if there were a different method that was connect-like, but targeted extended connect. However, I feel like defining a new method might be a challenge here, and it might be a bigger fight than the MASQUE working group wants to take on. If we have to do a hack of some kind, post is a reasonable hack. If we want something that's not a hack, I think we define a new method.
Okay, that is yet another option. Thanks. Ben?
Ben Schwartz. I was going to put in a word for a new method, extended connect. I think the cause of confusion here is that the upgrade path in HTTP is nominally optional for the server. So the server is always within its rights, in principle, to say, never mind your upgrade, I'm going to answer the request as you sent it. And if we send a connect method with a thing that follows it that isn't a host and port, then the server that tries to do that ignores the upgrade header is faced with a malformed request, which seems kind of ugly. So I think that's why people are looking for some kind of method like get or post, where at least that would be a well-formed request, even if it's nonsense. But a new method would let us have clear semantics and possibly say something like upgrade is mandatory with this method.
Thanks, Ben. Cheers. Mike was before Ben, I think. Yep, there we go. Ecker?
Yeah, MT persuaded me, so I guess I'm fine with anything, but including non-connect things.
Okay, thank you. That's helpful. Because at the end of the day, a lot of these considerations, remember this is upgrade. So in HTTP upgrade, you no longer have like the similar things that you would expect from the rules. So upgrade like connect are like weird abnormalities in HTTP land. And just thinking about this more, like these problems exist for WebSockets. Like it's not like these haven't been solved. Like if someone wants to deploy WebSocket today, they need to fix this. So if they want to deploy ConnectUDP, just point at, oh, the guy next door deployed WebSocket. Ask them how they did it. So that's making me lean towards there. But at the end of the day, honestly, I really don't care as long as we pick one. Lucas.
Hello, Lucas again. Just, I guess, adding more flavor to my not liking connect. It's that, if you read the spec that defines the connect method, it says this is how you should handle it, and this is what you do. And if you're a server that doesn't want to do that, then you don't, and you reject it. And you might even just say anything that has the connect verb in this part of the bytes that form the request, I'm just going to instantly respond with no. Like, this doesn't make sense on my deployment, my infrastructure. Now, if you add, if you add an upgrade header, you need to read that thing and then maybe also look at the contents and maybe decide to do something else. It might be too late for them to even bother wanting to change. But meanwhile, they may well already handle WebSockets and would just take that parsing path and add a new handler for a new value in the upgrade header, and it all makes sense. So just from a purely I would need to analyze this and understand the security considerations, it's a no-op if you were to use get, because it's already been done for some kinds of deployment.
Okay, thank you. Yeah, that sounds sensible to me. Tommy?
All right. Yeah, I just got in queue to say that I've been convinced by this discussion that we should just go with get. Connect clearly has problems. And as I mentioned in the chat, I don't think the overhead of trying to use a new method or even use a method other than get, which isn't being used with upgrade today, is worth the effort, considering that we don't really expect this HTTP1 use case to really ever be used in the wild. So it's not worth going through allocations or paving new ways for it.
Thank you, Tommy. Yeah, I fully agree with having less work for the editor, because that's me. So I'd very happily not create a new method. Martin Duke.
Very briefly, I will just say get, because of the wisdom of the ancients who did it with WebSockets, and maybe there was a good reason. And beyond that, just being consistent with the approach we have. But more than that, this is starting to smell like a bike shed, since everyone agrees it's a corner case that may never actually come up. We're spending an awful lot of time legislating this. Maybe we can take it to the list if there's other stuff.
Thanks. PHB? You are muted, PHB.
No, I'm not muted. I'm on the wrong microphone.
Yeah, we can hear you.
What?
We can hear
Okay,
you.
yeah, I'm just wondering why you're doing 1.1 at all. I mean, if you think this is a corner case, you think it's, you've got a complicated enough spec already. Why not just get rid of it? If people need to downgrade, let them sort it out.
That's a reasonable point. I suggested that a few years ago, and we got some pretty clear working group consensus that we wanted to support H1. So we decided to do it, accepting the fact that we didn't want to spend too much time on it. So what I'm getting from this discussion is that the folks who were against Get seem to, at least some of them, seem to have been convinced that Get seemed fine. And a lot of whatever, we don't care, please move on, this hurts. And I would like to not have to take out the hat of consensus, because that always works. So I'm going to propose we go with Connect. Can anyone really, really not live? Sorry, with Get. Sorry, whoops. I'm going to propose that we move forward with Get here. Can anyone absolutely not live with that? Okay, then we shall go with Get. Thank you very much for our traditional mask bike shed of the week. And what is my next slide button not working? So, fun fact, that was the last issue on the Connect UDP draft. That's why we spent so much time on it, even though it wasn't very interesting. And so this is my favorite slide because it's fun. We've managed to resolve all remaining open issues on Connect UDP. Where do we go from here? I'd be inclined to perhaps also move it to working group last call. We're in good shape. We have multiple implementations. This is out in production for some folks. Can we start that working group last call? Chairs, what do you think?
Our initial thinking
There's a
is
+1 in the
that
chat,
getting
apparently. Oh, sorry, Eric,
Yep.
I cut you off. Go ahead.
No worries. Thinking that a last call is probably appropriate for this as well. Let's try to wrap up kind of the issues that we're resolving here today and get that out for folks to look at. But I think when we are rapidly approaching the point of having nothing more to do for this one, and it would be good to get that stamped and wrapped up.
Yeah, and as with other, this is part of our process. Working group last call also kind of motivates people to read the drafts, and I'm sure they'll come, that'll get a bunch of review, which is also what we need. So I think we're in good shape. Okay, that was it with my slides. And so as we're clearing that out of the working group, I think we can start focusing on Connect IP, which, if I understand it, is the next presentation. Thanks everyone for listening.
All right. Hello, everyone. I'm Tommy Polly, and I am going to be sharing our other adopted draft, which is Connect IP, or IP proxying support for HTTP. And this is a collaboration between myself and the folks at Google and Ericsson, who had previous proposals around Connect IP, and we had merged the document before. And we have a pretty quick update today. So the main change in the last version of the draft was just to update things to align with the changes that you've already heard about in HTTP datagrams and Connect UDP. A lot of it is very much mirroring Connect UDP as far as how it uses the datagram formats, how it has support for contexts, for extensibility. The existing work we had done for the capsules to negotiate the different IP address routes and address assignments, that all remained the same as it was before. So we really have two open issues that we want to go through today that are interesting problems still to solve. And then the other point I'll mention is that we do need more interop testing on this. So far, a lot of the work has been done around basic HTTP datagrams and Connect UDP. Those, as we see, are getting pretty mature. And now I think it's going to be useful for implementations who are working on MASQUE to start playing with Connect IP and doing interop testing. I can say, for my own implementation, this is, again, still a to-do to really get ready for interop. But if you are interested in doing that, let's talk collectively about that and prepare for a checkpoint at some interim, or at least by the next IETF meeting, so that we can get some good experience with this protocol. All right, so let's dive into those open issues. The main one, which is interesting, is Mtu handling. And this is something that in general you have to deal with encapsulating protocols and proxies. To some degree, people need to think about it for Connect UDP, but this is really an interesting problem for Connect IP specifically. And the problem, which was raised in an issue that David wrote up, is that you can have cases where you have a small, quick packet size that is the actual kind of tunnel, and it may be too small to actually hold the minimum MTU that's required for IPv6, which not only is annoying to not be able to hold large packets, but it actually becomes a protocol violation, or like you essentially can no longer use this as an effective tunnel for IPv6. So I give two examples here of some of the sizes that you could expect. The first one is if you're on a normal 1500 byte MTU link, if you do the calculations and figure out how much room you have, assuming that you have relatively small stream ID numbers, etc., and packet ID numbers, you have plenty of room for a minimum IPv6 packet. You can actually have a pretty large packet going through here, over 1400 bytes. However, if you have the minimum quick packet size, then you are not going to be able to hold the minimum IPv6 packet size inside it. And this is particularly interesting because some quick implementations will start with a minimum packet size and try to explore up, which means that there may be times during your quick connection lifetime in which you aren't going to be able to tunnel certain packets, and then later you would be able to. So this is really an open question, and I'd love to hear people's opinions. I don't have a particularly strong opinion here of what should we do when we run into this case. You could have a failure on the request stream, essentially saying if you are trying to do a Connect IP request and you are using IPv6 and the other side knows that its effective MTU is too small, it will generate an error. You could essentially fail over by saying, if you have these unreliable datagrams going by that won't be able to fit, you could make them reliable by putting them inside datagram capsules and spreading them out over multiple quick packets, which could have lots of interesting consequences. You could have extra signaling, essentially within the capsule stream or something else, to say, hey, I'm dropping packets, or I wasn't able to send packets. And then practically, and we should probably do this as well as the other things, there should be a recommendation that if you are using a quick connection for Connect IP, you really should be starting it with at least around 1300 bytes of MTU, starting with the minimum 1200. If you're trying to use it for a tunnel, is not going to be a great idea. And even in cases where today we're using Connect IP, Connect UDP with Quick, we start with more than 1200 because we want to be able to send large datagrams. So what do people think? I see we have some folks in the queue. Let's start with Ben.
Hi. I think that we should, hold on, I'm going to mute the room. I think that the core specification here, the connect IP draft itself, should essentially note this as a problem. Be very clear about the issue here, and essentially note what is required to ensure that the inner stream is IPv6 compliant, and not attempt to solve the problem of stuffing oversized packets in the case where the MTU doesn't fit. I do think that we should solve that as a working group, but we should solve that as an extension to Connect IP.
So to be clear, like looking at kind of the options here, I kind of interpret that as being like the last one of just saying, you really should have your tunnel be big enough if you want to use IPv6. Otherwise, you've done something wrong and you need to figure it out or have an extension.
Yeah, that's a fair summary.
Okay. All right, thank you. Ecker.
We could just restrict ourselves to IPv4. More seriously, I concur with Dan. If you advertise yourself that you're an IPv6 carrying tunnel, then you have to carry minimum MTU size packets, or everything's just going to fall apart. So I think the question then becomes, what do we do? I'm not a huge fan of segmentation reassembly. I think I'd like to be sure that we're actually need that in practice before we do it. So I think really the question is, and so between these, between these options you propose, right? I think the first is kind of like, I guess maybe you can imagine doing that if you say like, well, I can only negotiate 1100, so I'm going to allow IPv4 and not v6. It's not like a totally crazy thing to say, though pretty gross. I don't think we should. I don't think adding capsule signaling is the right answer. So I think this last point is really an implementation point. I guess what I would say is that we should say, if someone asks for IPv6 and you can't do 1280, then you ought to reject it, and then you must reject it, and like we strongly advise you to use it, and so it's your job to negotiate up to the right size, whatever that size is, and we strongly advise you to do that by using large initials, because otherwise it's going to take additional round trips. So I think that the only mandatory piece is that you must reject if you can't carry the IPv6 minimum, but then some strong advice about how to get to the point where you're able to carry that minimum.
Okay, so that sounds like a combination of this first line of have a description of here's how you send an error back if you do the wrong thing, but then also focus on the advice of the right way to do it, of starting with a larger size.
That's my suggestion, yes.
Great, I like it. Lorenzo.
Hello. I haven't heard of this IPv4 thing that you're talking about, but so I mean, like you have a problem if the link that you're running on has an MTU of 1280, because then you the last option is just infeasible. You basically go back to the first one, which I assume is unacceptable.
I mean, we need something.
I mean, is it a downgrade attack? Is it a downgrade attack if the network, because the network you're visiting could be intentionally sending I don't know, right? Like, hey, my network is 1280, so you can't use connect IP on my network. My network, my rules. Do you want that? I don't know.
Or you can now only access the IPv4 internet through this tunnel.
Like I said, I don't know what this IPv4 thing is that you're talking about. So yeah, so I think it's either you could have a combination, which is basically I think the last one is good because it's the one with the least complexity, but you have to have, if you don't want to do number one, which I think you basically is a downgrade attack, then you basically need to have a fallback mechanism. And the question really is once you have the fallback mechanism, then why do maybe you can do the fallback mechanism first and use the last one as an optimization. I don't know. But you don't have a good solution either way.
Yeah. If I kind of combine the feedback I'm hearing from people, one option would be that we would, recommend to do the last line, have a way to fail it, as what the default of this draft does, but then to Ben's point, allow an extension in another document to describe if you're in an adversarial situation or if you really need to get this packet through because you're on a tiny link, but you also need to do IPv6. Here's a flag to do something like that number 2, but that's going to require a bit more work and analysis of the implication of splitting up packets. Okay. Rajiv?
Look, hi guys, can you hear me? Yeah. Okay, so my point.
You're very quiet for the room. If you can speak a bit closer to your microphone again.
My point here is more on the lines of, we should not be failing any traffic unless it's, an absolute essential, and there is no way of getting that data through. Especially considering the fact that MTU changes may happen in mid-through. Okay, there may be an intermediary ISP link somewhere that goes down and gets rerouted to an alternate link that just happens to have a lower MTU, and suddenly I'm in a situation where an existing connection, you know, uh, it basically ends up getting dropped because of a MTU change somewhere that I don't have control over. Okay, and it's not happening at the initiation of the connect where I can check. Okay, am I negotiating an MTU with my path to the remote end because my path may not be static. So I think the correct handling for this ideally should be uh, allow the connection, where a path MTU, issue crops up, wherein we don't fit in it, to allow segments to fragment and reassemble. That opens its whole can of worms, but probably pair that along with some sort of error signaling saying, hey, your packets are being fragmented. Maybe at, you may even want to put in a hop count or whatever else. But the idea is to have the sender get some notification that yes, there's fragmentation happening. So therefore, there's a degradation in the performance of the tunnel, but the tunnel doesn't fail unless it absolutely has to. Okay,
Understood.
and
Thank
and
you.
and it's up to the endpoint to say, okay, if I see fragmentation, maybe I make a decision as one of the tunnel endpoints to drop the tunnel and initiate a new negotiation to see if I can probably get the MTU back up. Maybe a new connect, bypasses some connection tracking, gets onto a different link. Cross your fingers and hope. But the point is that a running session may degrade because of an MTU shrinkage, but it should not fail. That's my opinion on this.
One question to you, Rajiv, actually, before you go. Would you be fine with specifying essentially this fragmentation reliability behavior as an option or extension that you could essentially say during setup, like, I support this?
That would work. That should work. Again, the question should be. I believe that having a flag might be useful if someone wants to explicitly disable it. But I still believe it should be the default option. Our default should always be try to get the traffic through, as best you can.
Yeah.
So the
I'd be
default
tempted
probably
to.
would be to have it on, but if someone really wants to ensure a certain level of performance or a certain level of reliability and does not want partial packets and stuff like that, give them the power to turn it off. That's all the more power to the implementer.
Yeah. Okay. Thank you. I'm a bit tempted to say instead, that it's something that would be an opt-in, but it could actually be an opt-in that would apply. We could also define it for Connect UDP for cases where you'd have very small MTUs there and you need to fragment datagrams.
Anywhere with similar behavior, this makes sense.
Okay. Thank you. All right. Mike?
Also of the opinion that we should try and get it through. It seems like if you're already building on top of capsules and HTTP datagrams, then having a datagram capsule is a relatively small lift. I may be mistaken about that. So I would think the simplest path is to say that your connection should have a large enough datagram or a large enough, MTU to be able to carry these without using a capsule. But if you need to, then you stuff it in a capsule and keep going.
Okay. David?
David Skenazy, Google. My thinking here is that a network with an MTU kind of that low is, for the outer one, is kind of borked, right? And we know how to handle those networks that are borked. Another example of a borked network is one that doesn't allow UDP. When that happened, we switched to connect IP over HTTP2. So I like that last approach of saying, if you want to do IPv6 over connect IP, just have initials big enough that if the network is borked, we don't use it that way. And that's just really simple. In practice, that's what I think I'll implement. And everyone's happy. Like figuring out other things seem like really complex, and given how much time we spend on simple issues, I'm terrified at the idea of how much time we'd spend on complex ones, so let's keep it simple.
Cool. Gory? And if people, as they're done being in the queue, could remove themselves from the queue, that'd be great.
Hi, Gory, I'm just joining the queue. No. Okay, so we went through this when we did DPLP MTUD, which wasn't kind of trivial because there was lots of these cases, and this is that final case of what do you do when it doesn't work. So let's go right back to the beginning. I think the last bullet here is the right thing to do. Just send a big packet across it and see if it works. Of the right size, yeah? I mean, if you need a few extra bytes, check it out, make it work.
Yep.
Right, if it doesn't work, what the heck do you do? I mean, do you want to fragment and reassemble here, and then somebody tries DPLP MTUD over the top and tries to figure out the fact that it's not broken, and then you get kind of brokenness twice, or I don't know. So there's the warning, kind of like, don't do this at multiple levels. Second thing. The third thing is, as you go down these numbers, especially with IPv4 and UDP, you're going to hit barriers. So if the path changes, it will change that MTU if you start getting into the bigger numbers. So you've got a problem there as well. The paths might not stop working later on. So we have to detect that somehow. And if detecting it simply means it doesn't stops working, then maybe that's a good signal to the app. So maybe simple's okay.
Right. Yeah. But you may need to close your stream if your MTU drops.
Yeah, you have to figure out lack of connectivity and just close the stream.
Exactly. Yeah. All right. Martin?
Martin Duke, Google, as an individual. So this strikes me as like not a new problem. I mean, IPv6 over IPv6 tunnels have it, and I'm not like an interior guy at all, but presumably there's some sort of received wisdom on how to handle this sort of case, and maybe we should take it. Secondly, this is certainly quite acute for Connect IP. This also exists, I think, as somebody already said, for Connect UDP, and I know we just closed Connect UDP, but if there's something we decide we should do here, I mean, we could have a reference, which would be sad, or we could just cut and paste the text or something. But this is not just a Connect UDP problem, or Connect IP problem rather. Thanks.
One comment I would have about solutions at other layers of tunneling is, there is something we need to do here, just because with a Connect IP request stream, it is a bit more stateful as a proxy here, and we do need to just know how do we spell the semantics of the error handling in HTTP. All right, Miriam?
Can I just jump in as co-author to answer Martin? This problem is specific to Connect IP. in the sense that IPv6 has a minimum MTU of 1280. For Connect UDP, that's not necessarily the case. And so for those, you can still have things be functional, right?
Yeah, for certain use cases, but like for instance, if it's an IPv6 only proxy, you absolutely have this problem. And of course, you know, as you know with Quick, if you
Wait, no, so if it's IPv6 only where? Underneath or inside the tunnel? Inside the tunnel that only applies to Connect IP.
So maybe a cleaner example would be a network that only lets you do 1200 byte quick packets, and then the Connect UDP you're trying to do over that is itself to a quick server, and then you wouldn't be able to get the minimum quick packet size through it.
Yeah, that's the simplest example. I was trying to generalize it, but as I think about it, maybe that doesn't work. But nevertheless, yeah, so clearly the Connect UDP use cases where it's just plain old UDP running like tiny little packets and you don't care. But there's still a problem here. As are like inherent to all tunnels when, you know, sometimes the tunnel will break your application because of packet size.
Mia Kulevind, I would like to at least see or work on a solution that uses capsules. We have these capsules, we have these reliable streams, and just putting some IP packets on that doesn't mean that it's IP fragmentation for me. I think it should just work. I don't think it's as complicated as we think, and if it's easy, we should do it.
Okay, thank you. Lorenzo?
Lorenzo again, I'm going to disagree with myself. I think that
everything should be IPv4? Oh, boy.
Exactly, yeah. I think, yeah, we have this problem with, I think we have this problem with Connect UDP, unless you want to go into like saying that UDP is a stream. I don't really know if it is. I think it probably isn't. So what I would say actually is the last one, okay, so the last one is, like, all of these are more complex than just to fail. But if it's, unless failing is in any situation is acceptable, then we need to, then simplifying the implementation means only supporting one way to do it. And that basically means number 2, actually. So basically, like, if you're implementing, you want it to work the same way all the time, regardless of what happens to you. And so, like, Rajiv's point earlier was like, yeah, the network can send you a packet too big at any time, and now the IP stack is obliged to send a smaller packet. What do you do to that Connect UDP? Do you fail it? Suppose you return an error to the app, but that's also pretty bad, right? It's kind of even like a denial of service vector, right? So at that point, you know, I think something, basically, I'm going to display my ignorance here. I don't know why the capsule must be reliable. You know, can you make it, like, is that the problem?
So the way a capsule works is that these are, it's essentially, it's a way to put your datagram on the quick stream, on the HTTP stream that is the reliable stream, because you're not able to send it within one packet, so you have to send it across multiple.
Right. So it forces you to enable retransmission. Is that the problem?
Yeah. Yeah. Exactly.
And there's no way to make it like unreliable. Just to put a fragmentation.
You could introduce fragmentation, right? Like you could have like a separate fragmentation mode of putting it through unreliable, and that's its own can of worms.
I guess I would say, like, whatever we do it, however we do it, it should be the same thing all the time.
Okay.
For implementation simplicity. Otherwise, you end up with these dark corner cases that, like, you only happen sometimes, and you get, consider IP fragmentation. It's like the boon for security researchers everywhere. You know, as soon as you look at it, there's a bunch of, like, you know, corner cases overlapping, you know, negative length. So I think, you know, might as well just do it all the time. Basically fragment everything all the time. As long as you can get the performance overhead to minimal, then I think you're okay.
I mean, the benefit of putting it over a capsule is, even though you have the extra retransmission, it's extremely simple, and it doesn't have all the caveats that fragmentation would. Yeah. Ecker.
Yeah, I'm like super unenthusiastic about putting it over a capsule and making it reliable. That changes the entire congestion dynamics of the system, because once you accept it, once you accept the packets, now you have dual congestion control it out. So that seems like extraordinarily undesirable. And not just with version control, but with vision systems now, right? This is sort of an issue for UDP, as people were saying, but every UDP system I know either either assumes a minimum. I mean, so first of all, like people don't build UDP systems that only work over IPv6 because that would be silly. And so so every UDP system that I'm familiar with has to be able to handle packet sizes that go down small, because you have to do. I mean, or you have to just say I'm going to fail over IP people with small IPv4 links, right? So like if you look at like the DCLS handshake, for instance, it's willing to negotiate downward below 1,000. And as I say, if you don't do that, you're like operating at risk of like the thing just not working in general, right? I'm no level of fragmentation. To my knowledge, the problems of fragmentation are largely due to attempts to do passive packet inspection by stateful IP inspectors, and because we're encrypting things, that's largely not the case here. So I'm less concerned about that. I guess I would also observe that this is putting them in capsules is fragmentation. It's like just a different form of fragmentation that treats them into infrastructure. I mean, it's inherent in a quick system, in any kind of system that breaks things apart and puts it back together again, whether it has retransmission or not. That is like a form of fragmentation. So I don't really understand why one would think that it'd be substantially better to have a reliable and in fact, if there's no data loss, fragmentation and retransmission are identical behaviors, right? So I think the question we have to ask is, can the system ship at all without having some mechanism for handling this case? And I think the question, and then the question becomes, I think, how bad is it? So as we've already described, it's possible to discover at the beginning whether your path handles this. And the question becomes, can your path shift in a way that you do not have, you no longer can handle the MTU, and does that cause some sort of goofy problems, right? I think MT was worried about that. I'm perhaps less worried about it. My instinct, I think, would be to say, let's try feeling about this and see if people encounter problems, and if they do, we can always add a mechanism for doing this. But I think if we have to do something, then we should just need to do a fragmentation reassembly system, because because it's the minimal change.
So one question there. I'm getting a lot of echo. The case of doing fragmentation over capsules, which I fully agree is fragmentation, it's just like fragmentation with retransmissions, is essentially the exact same behavior that you would have in the case that David mentioned of, if I start big and I have to fall back, I'm falling back to HTTP2, and HTTP2 for Connect IP only ever sends them over reliable capsules. So to that end, I could argue that if I'm having to deal with a world where I have a fallback to H2, I already need to handle the performance characteristics and everything else of going over reliable capsules. That is a reality that we have to deal with.
Well, I see with the argument, I guess I get fair enough, although I think I turn the argument around and say, if you're going to bother to absorb the pain of having the retransmission logic, in this case, why not just use H2? I guess one question I think it's worth asking about, is let's distinguish between detection and I guess one question to ask is, what does this actually look like? So I think so someone sends you a packet which at the bare limit, which was at the bare limit before, and now for some reason because of a path shift is below the limit, right? And so the packet gets dropped along the wire somewhere, right? Induces a too big quick packet, it gets dropped, right? So I mean, just to recap what I'm saying, you think the MTU that you're running over is 1300, but actually it's going down to 1295, right? And so you send a packet that's 1297 and it gets dropped, right? And so now, so now what, right? So you have to detect that case, and you have to fall back to small. You have to know to do something, right? And that thing, something is either start fragmenting packets or start tearing things down, right? I guess so. Let's start with that question: is how do you detect that case? And the way you detect that case is by repeatedly not getting ACKs or packets right at the bare limit, right? And so And unless you want to do some sort of goofy DTLS-y thing, like so what DTLS does is, when it starts, is it like says like, well, start at like, like 1280 and send like 2 or 3 times, and if it doesn't work, I can assume it's going to be too big and start backing off. That's like not really acceptable behavior for like an ordinary system, right? And so, and so I just don't understand, like it seems to me like that, that you're going to encounter like 4 or 5 round trip times before you realize that you have to start fragmenting or doing some other thing, right? And at that point, like, is that really the behavior we want, or would it be better to say like this is going to fail the connection and start tearing things down? So I guess I'm sort of talking myself back into like I think we should just like fail, because like I think that the situation otherwise is going to take an enormous amount of time to respond, and the response is going to be kind of a pain in the ass. And by the time you already lost a lot of packets, right? I mean, you may not have lost them actually, but you've lost them operationally.
All right, thank you. Miriam?
Yeah, me again. So I think there are possibilities to use unreliable datagrams and define a context or whatever, where you have like a dependency between different datagrams and you can only deliver them if you have them all or whatever. That is possible, but I think that would definitely be an extension. We have reliable capsules here, and yes, I think it's easy to use. I don't see a benefit from falling back to H2 instead, rather than falling back to capsules, or at least trying to find a solution to fall back to capsules. I think that's the tricky part, like when you fall back. But capsules are easy to use and give us what we need.
Yeah, I agree. It's very equivalent to falling back to H2, except you just don't have to now bring up an H2 connection to do it. Okay, Rajiv?
Up the point that while it is quite tempting to say, hey, if we encounter this case, just fail the connection, that keeps our implementation simpler, cleaner, less possibility, like Eric mentioned, of losing a 2 or a 3 or even a 5 round trip time cycle, just figuring out that we need to start enabling fragmentation. All that we're doing is we're basically pushing the ball up the stack, and now the applications that are using this tunnel that now have to understand and deal with the fact that a tunnel that I thought I had set up is basically going to vanish, out of the blue because of some network change which has nothing to do with either of the endpoints. Right. So which means I probably have no visibility on when a tunnel may completely just rip out and die under me, and all the error handling, reconnect, all that logic now has to be borne by the application end of things. Okay, so while it might be interesting to target simplicity here, there should be some level of understanding that if we make it too simple, we're not simplifying the entire solution. We're only simplifying our piece of it and pushing the complexity somewhere else. Yeah, so just that point that I wanted to make over there.
Thank you. Thank you. And we have Lorenzo again.
Yeah, just always do everything in capsules. I mean, there's not even a problem. Like, traditionally, if you retransmit something reliable, you have like a compounded retransmits. But if you unless you have like really aggressive timers above you, the app will just see no loss and it won't retransmit. It's a simpler code path. It runs. It's the same all the time. It's the same as UDP. Probably simplify the implementation, and it'll work all the time. And again, like the Rij's point as well. Like if you fail it, you can't just fail at the beginning. You have to fail in the middle, and you basically are introducing the possibility that the app will see an error halfway through, just when it happens to send a large packet or whatever, or if the routing changes. It's like super unfriendly to the app, and it like increases the complexity of the overall system. Right? I think it should just work all the time, which means, yeah, just do the same thing all the time, put them in capsules.
Ecker?
Sorry, but I feel like I have to reemphasize what I said. That doesn't solve the problem, because the problem is discovering when you have to think more datagrams. And so just putting them in capsules isn't enough of an answer. You need an answer for when the quick connection decides it has to do enough PMDUD discovery or something to go back to the more datagram. And so like until someone poses an algorithm for that, I feel like this is not like the PDF.
Right. I mean, you could certainly do something where like let's say I'm doing quick migration and like I know I changed MTU and like the tunnel has like a very clear event, then you could easily say, okay, now I'm going to switch. But yeah, it's the things that a quick implementation wouldn't.
Right. I guess all I'm saying is like when we designed Quick, right? Quick was designed like basically under the assumption it's going to be used for H3, and like H3, like the rule is pretty simple. Like if things like don't work, you just tear the connection down and start over again, right? And like so, we made hand waving stuff about having it work for things that weren't H3, but like we were willing to like accept this kind of failure mode in H3 because it just didn't matter that much. And I guess what I'm saying is if the argument we're offering is that if the argument here is that we don't want people to take weird mid-connection hiccups, right? Then we actually need to find an algorithm that does not result in weird mid-connection hiccups. And merely saying send over capsules does not accomplish that because you're still going to take multiple round trip times before you recover enough to send things in the small datagrams that they actually traverse the network. And so, like, I think like if people want to go that route, like we need a complete answer. That answer has to like prescribe enough of an algorithm that like under unknown topology shifts, which is the alleged problem here, apologies you're not aware of, that you still recover properly. Because if the answer is like it's known topology shifts, just do PMG discovery at that point, and if like the fact and tear the connections down if you don't meet the basic requirements, right? So I think it has to be unknown topology shifts, and it has to be fast. Otherwise, like someone just took 4 on trip times and like not going to be very happy about that. And I don't know about like and the rediscovery. I mean, the retransmit timers are pretty fast, like on these endpoints. Once you have established the round trip time, so like so if we're going to take 4 RTTs to discover this, like the other side's going to retransmit in that time period.
Yeah. Okay, I think we have drained the queue. We don't have consensus, but we do have a lot of good input. So thank you for all of that. I think it's a very useful discussion. Yeah, there's a lot of good stuff on the chat too. So hopefully we have the notes that we can go back to and the video we can go back to, and we can come up with a proposal for next time. And hopefully also we can have implementation experience and actually try some of this out. The one other issue is related. It's a broader question about error handling. What do you do if you receive a packet in your HTTP datagram that is something that you will refuse to route? So let's say you set up with your capsules a very specific route or a limited route, and now the other side starts sending with an invalid source address that you didn't assign to it, an invalid destination that's not routable for you. Essentially, you have the options of you can just silently drop it, you can try to drop it and send something back as IP packets within this tunnel as ICMP, or you can use something at the HTTP layer to send a capsule or close the stream or do something kind of at that H3 or H2 level. Do people have opinions on this? Rajiv?
Would be to stick with option 2. That most closely mimics what an application would otherwise have seen if it were communicating on a pair network. So you'd expect them to already have the mechanics to handle stuff like that and deal with that. And that also, brings out the possibility that, especially in case of, say, a proxy, which is not directly application itself, but like think of it like a soft proxy in between, proxying traffic from an application. That makes it easy to just pass the error on, pass the traffic on, and not really have to worry about doing too much in terms of understanding the traffic and then translating it into something that we can in turn communicate to the application. So this way, everything just goes as it would on just any other network tunnel.
All right, thank you. Corey?
Hi, Gori first. Two ICMPs are kind of nice.
Sorry, can you speak closer to the mic, please?
I can redo the mic. There we go. Two ICMP messages are particularly nice. PTB, if you translate it correctly, so that when it comes out, it's the quoted payload is actually the one you want to respond to, so it can be verified, rather than just a random PTB of the outer tunnel. And TTL, because then you can, as an operator, kind of debug and figure out what happened with that tunnel. And without it, tunnels become very difficult to understand, and this is like a tunnel. Other stuff, I'm not really so sure about because I don't know what to do with it. So that would also be my two recommendations.
Okay. So, again, multiple people speaking up for doing ICMP signaling and making it tunnel friendly. Miria?
Sorry, just a clarification. Where do you send the ICMP message? Isn't it within the tunnel?
Presumably, yes. Right. So you would send it on that datagram with the quarter stream ID to say, you sent this to me, and like, no.
Yeah, so why, I mean, like, this is not visible to anybody, right? So in that case, I would rather use capsules, because that's
But
the way we
it
test the
allows,
trap.
I think, the person receiving the ICMP to do a very simple thing of, let's say they've implemented their quick stack behind like a virtual interface such that the application actually doesn't have any idea that it is going through a proxy. Like you're using it as like a VPN tunnel. At that point, if you re-inject the ICMP into the stack, it could look to the application like they were on this virtual network. They get the ICMP that they would expect based on the packet that they think they formed.
I guess you could still generate an ICMP message locally if you really need that.
Right. So at that point, it's a question of does the server have to do it or does the client side have to do it?
It seems like a dependency to a different protocol, which is not necessary to me.
David?
I'll just, since I'm next in queue, go from here, so I'm lazy. What we're building here is, sure, a virtual tunnel, but at the end of the day, what it is an IP link. And the internet protocol uses ICMP when something goes sideways. And so, in a way, we don't need any normative text here. Like the two sides of a connect IP tunnel are IP routers, and those are very well-defined components in the IP spec. And if a router doesn't want to forward something because of its policy, because of its MTU, because of anything it fancies, the spec says you send ICMP. So that's like what it comes down to. We don't need to invent anything. We don't need to really say anything. Perhaps having some implementation guidance of saying, by the way, this is how this is done. Like, if your stack pops out an ICMP packet, don't freak out. Seems useful, but like we don't need to design anything new using a capsule or something. We already have this in the IP specs.
Yeah, me again. I agree to that. Like if we want to use ICMP, we maybe give a recommendation, but we don't have to say much because that's like not our business. I wonder if there's any benefit of silently drop, because like silently drop seems to be an option when there is kind of a security risk or an attack risk or whatever. I don't think that's something we have in this tunnel. So I think it's better to be explicit than being implicit, making sure that the other end knows what's happening there. And if we really want to make sure that the other end knows what's happening there, we should have a feedback mechanism within our protocol.
Well, we already do, and that's ICMP. Why do we need something additional?
I think she was just commenting on the option one, that option one is bad, which I agree.
Well, that's fair, but we shouldn't preclude it. I mean, just like for IP routers, there are many different cases where you don't necessarily want a signal. Let's say you're under load. So, like, giving guidance seems reasonable to me, but at the end of the day, we're sitting on the shoulders of many hundreds of pages of IP specs. You don't need to reinvent those.
Yes, so if you have a reason that's covered by ICMP to drop it, you can use ICMP. We don't have to care about it. It's not our business. If you actually drop it because that's not what you requested in the connect request, and like I'm providing you a connect service, and I believe that like you are not doing what you asked me to do, or like what I'm providing to you. Maybe it's good to say this explicitly.
Yeah, I agree with that. That sounds like useful guidance.
Rajiv?
Second, what Viraj just said, that silently dropping in this particular context, is probably something that we strongly advise against, in our draft text. Because in the IP router world, silent drops have a very valid use case, either in terms of trying to protect the network integrity under either attack or high load conditions. That makes a lot of sense. But in the context of a tunnel environment, which we are talking about, which is a much more uh, you know selective use case of general purpose IP routing stuff, you've actually got an environment where you have a stable endpoint at both ends, okay, and you've already negotiated some amount of uh, you know uh, connection semantics before you've started traffic. So at this point, deciding to silently drop traffic after doing that seems quite uh, you know troublesome for the remote end. So I guess that you should always have a mechanism where uh, a silent drop should not be allowed unless in extreme conditions.
Philip? Philip?
We're not hearing you in the room either, Philip.
Okay. Ecker?
So I was struck by what David said a few minutes ago about standing on hundreds, if not thousands, of pages of RFCs. And it seems to me that this is an aspect of Mask, which is like essentially like every other tunnel system we ever built. And as Martin said, this is like acting as a router. So like, I guess I'm really hoping that we can like, that we can like draw on those other documents to behave the way that whatever those other documents say you want to do says you want to do. So I guess I would kind of like to. So I'm in particular say invalid source requests. Like why isn't this just like address filtering, like ordinary IP address filtering, right? It's BC56, right? Why can't we just say behave whatever that says to do? So you know can we maybe just focus this on topics which are distinct to Mask, if there are any? And behave those and change and just define those behaviors, and for everything else, just punt to like whatever the existing RFCs say to do. I mean, like, we start require some research, but like that seems like better than trying to like derive a lot from first principles again.
Martin Duke, Google. So I guess I don't understand. I mean, I went back and looked at the draft just now, and I guess I don't understand the case where where the client could legitimately send a packet with an invalid source or destination address, right? Because those things are specified through the capsules or the host request.
So let's say you do a capsule negotiation. You say the other side says you can send from this source address and you can send to these addresses, but the content of my datagram is a full IP packet, and so I can put bad IP addresses in it.
Well, yes, clearly it's physically possible for them to send everything, but that is like clearly a protocol violation.
What do I do if I violate what you told me I could do? Yeah.
Well, I mean, close the stream. Like if people are ignoring what the proxy told them to do, then I mean, I think that's. I mean, Quick is a different layer, but in Quick, like anytime you violated the spec, we just kill you, and I think that seems totally appropriate here. I mean, ICMP is a different world where you don't have these pre-negotiated things, or the context for ICMP is a network, a Wild West, where like you don't really know where the packet came from, and and you don't know what's authorized and what's not. But like here, all this stuff is pre-negotiated. The client is authenticated. If the client is misbehaving, just kill the stream, if not the connection.
I mean, there are certainly other cases where you are, the other side knows what you're assigned, like an IPsec tunnel can assign you something, but also your router will know what addresses you can send from that you've registered. So there are other cases where you could receive ICMP errors that are equivalent.
Fair enough. Okay. I mean, like my argument for like a general IP case may or may not be 100% correct, but I think the point stands that I don't see the downside in just killing the stream.
Marian?
Yeah, actually, if the source address is wrong, there's another option, which means would be just rewriting it silently without letting the endpoint know. Maybe we should just not specify it in a way that this option isn't allowed. I mean, it's not necessarily a recommendation, but in some cases it might be useful. And then
it would only work if you have a single address assigned. Yeah.
And then the other option, the other point is when you have the destination address that's not allowed. In that case, actually just dropping it might be an option because that would be the usual behavior you expect, right? If an endpoint is not reachable, you might not get a reply. However, I think it would be nice to at least have some kind of signaling mechanism to tell the other endpoint that something went wrong.
Can I relay from Jabber?
Yes, please.
Philip says, inventing a new mechanism makes the world, especially in regulated environments, more complicated. So ICMP inside the channel is a good guidance. Still, if we want to signal bad behavior with respect to the tunnel configuration, sending the error as a capsule as a protocol error makes sense, and turn it into an ICMP on the client side makes sense.
Okay. That's good feedback. Ecker.
So much as I'm sympathetic to paradigm connection, if people behave wrong, I think that's a mistake in this case because imagine the case where you have the version of Connect IP where you basically connect two networks together. Then you are having like any misbehaving device, of which I assure you there are many, potentially our connection be torn down. And so that seems like in particular and imagine a situation where you're effectively proxying like a customer network, and now you have like thousands of devices that which you don't control, and then one of them maliciously or non-maliciously generates a bogus IP, and the whole thing is torn down. That just doesn't seem like a acceptable situation. So I think again this like seems like a situation where we're standing on the shoulders of giants, and we ought to like steal from those giants, and we know how to this is like building a transit network, so like you should behave that same way. So I don't think so I think it's one thing to think like this is like the version where it's like the customer VPN, in which case I like agree with like Martin that like the customer VPN starts generating bogus things, because he's like going to Euro Netflix, then maybe you can tear him down. But I just don't think, I think there's a general matter of not acceptable practice.
I'll concede the point.
Okay. Oh. All right. I think we've trained the queue. So those are our two open issues. Lots of discussion. Thank you, everyone. The only other thing is, if you're interested in doing interop and testing, let us know. These are some of the things we need to work through. And we'll see you next time.
All right. Thank you, folks. Extra thanks to our note takers and Jabber scribes. And we have now come to the end of our agenda. I think we're looking to do some extra interop, as Tommy noted, for Connect IP, as well as folding in some progress on those issues. And with that, thank you all.
Thanks, everyone.